Good afternoon. Our topic for presentation is the possible applications of variable renewable energy forecasts and dynamic ratings in the Indian power system. So in this, we have basically gone through the different practices which are currently employed or are there in the literature and have suggested some applications which may be introduced in the Indian power system as well. Currently, in the Indian power system, forecasting has been done by two entities. One is the renewable energy plants themselves or their aggregates, which have been recently introduced, known as the qualified coordinating agencies. And the main purpose behind their forecasting is for scheduling and accounting, and the deviations are calculated based on this forecast. While on the other hand, the load dispatch centers themselves can also perform forecasting, and the purpose for this is maintaining the grid security. They can either do it themselves or through the renewable energy management centers, which are also coming up. So we have suggested the different applications in a qualitative time format for three different entities, basically the variable renewable energy plants themselves, the load dispatch centers, and for the distribution companies. And it includes applications from trading, ancillary service, ramp event, and residual load. So one of the first applications could be for trading the renewable energy production in the power exchanges. So for that, the plants themselves will need the 15-minute forecasts. And this is just an example schematic. The point here is to show that the actual generation may vary many a times from the forecasted generation, and that has to be taken into account. This type of forecast would primarily be done by the VRE units themselves. And for the load dispatch centers, they can use the aggregate generation forecast to determine the ramp events in residual loads. And this ramp events can be quantified using different flexibility metrics. I have not included references in the slide, but these are already there in literature. So for the DISCOMs, since with the penetration of rooftop and small distributed generators into the distribution grid, since the DISCOMs, they need to provide schedule to the load dispatch centers for their schedules. They will need to estimate how much is the expected demand, and this will change because of the rooftop PV and the distributed generators which will be inserted into the grid. And the DISCOMs can also use this for the procuring power from the power exchanges. In the medium-term future, with lots of wind and solar in the grid already, it is expected that the VRE units and the QCS, they should start providing some ancillary services. So we have there are methods of the different methods for wind turbine control strategy and PV power plant control strategy. So using this, the primary reserve can be provided, but unlike conventional generators, in VRE-based generators, the power available would depend on it's volatile. So it's necessary to determine what's the firm component of the power which could be available for these services. And similarly, when the penetration of renewable energy-based sources, variable renewable energy-based sources increase in the grid, they can also start providing the reactive power ancillary service using their excess converter capacity. The load dispatch centers and DISCOM control centers themselves can use these generation forecasts for other purposes, like estimating how much reactive power is potentially available from the control area. They'll need to use active power aggregated generation forecasts and some converter estimates. Apart from that, the congestion management is another field where this may find applications for day-ahead congestion forecasts and also for intraday congestion management. DLR or dynamic line rating can also be a very advantageous in this situation, because it would allow the system operator to utilize the excess capacity, transmission capacity available, which would not otherwise show up in the static line ratings. And the idea here is that it is not necessary to, may not be necessary to model each and every branch or each and every line in the power grid, but it is also possible to make nodal models which only illustrates the critical branches, which are congestion-prone branches, and then use some generation or power distribution factors to determine what portion of a particular generator, how that influences power flow over a particular branch, and especially for congestion-prone branches. And here also, VRE forecasts find application, because to know how much is the generation, you need to know, you have the forecast. And this is just an example diagram. The depicted lines and nodes depicted in black show the state grid. So the state grid would take information, forecast, schedule information from the VR units, from the conventional units, from the consumers, and also the open access users. And then they would send the interstate flow. They can send this information to the regional grid, and the regional grid, on the other hand, acquires information from many other entities, like the VR units, interstate VR units, and interstate conventional units, and also from interregional flows. The complete coordinated exchange of information between the state dispatch center and the regional load dispatch center, based on forecast, could could help in mitigating congestion situations in the grid. In the long-term future, since by this time it is expected that VR units would occupy a substantial portion of the total generation base, so it is expected that they should also start providing secondary ancillary services too. Now, the one method could be based on the calculating how much firm component is available for this as a reserve, and based on some interval, confidence interval. And so if the VR units can participate in both energy and reserve markets, then of course the question comes, how much quantum of available potential should be allocated for the energy and the reserve markets. And in this case, the forecast information can be used in optimization algorithms, including the price inputs of the different markets, to arrive at the most profitable portfolio. If the concentration in increased volatility of the VR units will also may also result in an increase of the reserve requirement, particularly in the secondary and tertiary frame. And now this reserve can be taken into account either explicitly through setting reserve dimensioning, or it can also be implicitly included into the unit commitment process. For explicit dimensioning, there could be empirical formulas, or it can be used, or it could also utilize the historical error data and forecasts, and the day-ahead generation forecasts to obtain a probabilistic information of the imbalance which can be expected for the next day. And of course, a certain portion of this imbalance, reserves can be scheduled in order to accommodate a certain portion of this imbalance. Yeah. And for the implicit reserve procurement, what could be done is that different scenarios of VRE generation forecast errors could be considered. And in the unit commitment procedure itself, reserve could be allocated and procured in such a manner that any scenario, if it happens, that the reserve is sufficient to meet that. Or it can also be relaxed a bit so that extreme scenarios which have a very less probability may also be not considered. The DLR, which is used for real-time line rating, since this can also be used in a day-ahead framework, there are already papers in literature which show that it may be possible to use the DLR in a day-ahead framework in a probabilistic manner, so that to know the expected capacity on a day-ahead basis and the range of errors associated with that. Finally, the distribution grid, which primarily operates like a passive unit, must convert itself into an active network. So, which means that it needs to start performing scheduling of the different entities within it. And here also we see that generation forecast find utility, because without knowing the VRE generation forecast, the DISCOM grid will not be able to correctly determine how much power it should import from the grid, and for the how to set the pumped hydro, or for example diesel generators to schedule, and this way they can arrive at a final schedule for the DISCOM grid. Thank you.